Hey, what's good, people? Mr. Zensphere here, back with another RENOISE tutorial. Today we're going to be looking at some improved methods for native FM synthesis, kind of using a similar principle to the first FM video that I did, but an entirely different method of controlling the modulation. Just to give you an idea of some of the sounds that you can create with a method like this, we've got this instrument built here. Sub in a different waveform. Let's throw a saw wave in there. And of course, you can have however many waveforms of different types that you want as oscillator sources. So let's go through how to build this instrument. Maybe I'll just give you a quick overview first. Basically, we're using the pitch modulation section with the pitch range set to the maximum value. And we're using an operand, and then that operand is tied to macro 1. And then we're controlling macro 1 through our effects chain. We have a doofer that has the macros linked to the instrument macros, and I'll show you how to make that in a minute here. And then we have an LFO to control the reset rate of a second LFO, which is our modulation shape. So this is the shape of our FM waveform at the moment. And then there are some optional means of kind of modulating the FM amplitude as well to give kind of an evolving waveform over time. So I'll start a new instrument and we'll see how to make this thing. We'll start with just a sine wave because that's nice and simple, about as basic as it gets. And then the first thing you want to do is go into your modulation tab and go to the pitch section. Set your pitch range to 96, which is the maximum pitch range. It doesn't have to be 96, but this gives you kind of the widest range of frequency modulation to work with. And then we're going to go ahead and assign this to, we're going to bring in an operand device, and then we're going to assign this macro to our operand value. And then let's go ahead and name this macro. You can name it FM, or you can name it frequency, or whatever makes sense to you. But this is basically a bridge between our effects section and our modulation section. We can modulate this directly in the modulation tab, but you'll see that we have quite a bit more flexibility if we do it in the instrument effects chains. The next thing that we want to do is, if you don't already have my macro control doofer, which is available on my Gumroad, you want to make something comparable. You have to do this in the mixer section. So let's just find a nice empty track here. I don't think there's anything going on this one. And we'll come down to our DSP chain here, and we'll create a doofer. And then we'll also bring a instrument macros device and drop it inside the doofer. Okay. Now at this point, we can save this. So you would right click here. You can see all my doofers, I got 1,000,000, and hit save as, and name it whatever you want, maybe macro bridge or macro control or something like this. And then you can access this in the instrument effects section by creating a doofer and calling it up via the preset menu. So I'm just going to go ahead and open my macro bridge. And this is very simple. It's just an instrument macro section with the doofer macros linked to each instrument macro. And this allows for kind of two-way communication between my macros and my effects section. So now if I change this macro 1 value, I change my macro up here. And you'll see that this is useful because then we can modulate this using other modulation devices in the effects chain to create our FM synthesis. So the next thing that we're going to do is we're going to bring in an LFO. And this LFO, we'll want to create a custom LFO, turn the amplitude all the way up, and we'll turn the frequency, we'll just leave the frequency where it is for now. Go ahead and open your external editor. And I found that we get the best results from this LFO using the highest resolution that we can. So as you may or may not know, our maximum resolution or rather our highest rate is 1 line per cycle for our LFOs. And this is a little slow for FM synthesis or this kind of like pseudo FM synthesis, whatever. We are modulating the frequency. So in a sense, it's maybe a truer FM synthesis than the phase modulation synthesis that is, generally called FM. So we're going to be using this LFO basically just as a ramp to control the reset of a second LFO, which is going to modulate our frequency value. So what we want is this ramping behavior because that's going to scale through our reset value on our LFO in a linear, kind of predictable way. But because 1 line per cycle is our fastest rate and it's not fast enough, we're going to create a custom LFO that has multiple cycles of this rising saw wave so that we can kind of cheat that 1 line per cycle rate. So what I'm doing here is I'm creating 100% value at 256 and then 0 at, let's see, it looks like we got 258. We want to just bring this down to 257 so it's as tight and as clean as we can get it. Bring another one up to 512 and we'll just change this to 512. Bring another one down to 0. Bring this to 513. Oops. And I screwed it up. Okay, so let's do 512 and value is 100. Create another point here and type in 513. And then we'll do the same for 768. And create another point here. And we'll do 769. And just so we have kind of symmetry within this, we will change our 0 point to 1. And we're going to create a point of 100% at time 0, right? So then we're getting this highest resolution ramp down. So we've effectively created a 1/4 line per cycle, 0.25 line per cycle rate rising saw LFO. And again, the utility of this is that we're going to set this to control the reset rate of this second LFO. So we go to LFO2, reset rate, and now you can see that this is triggering at basically a faster rate than 1 line per cycle. So we'll set the destination on the second LFO to our doofer macro 1, and now we have our FM synthesis. Right, we've got something moving here. So one of the advantages of this method is that now we can create whatever wave shape we want for our FM waveform by creating that shape here in the LFO window envelope. So let's assign some kind of useful macros here right off the gate, or right out of the gate rather. So let's assign the amplitude to macro 2. We'll call this FM amp. And then let's assign this frequency value, our reset rate, to macro 3, and we'll call it FM rate. And now we have a little more control over this. Now we can also use this offset to scale the frequency. So we'll call this frequency scale. Now, I find that often, because we're doing this at modulation rate and not at audio rate, it's very common to get artifacts, especially when using things like sine waves or other kind of like harmonically poor source material. But if you use something that's kind of more harmonically rich, like a saw wave or a square wave or something with some more harmonic content, a lot of that, a lot of those artifacts get masked. So this method is good for making, kind of harmonically rich, noisy, screechy LFO sounds, or rather FM sounds. Although you can, if you dial it in, you can make some nice tonal sounds as well. Mostly at the lower end of the FM amp scale. And, if you find that you're just not using the higher values, you can always change your scaling here to create a more usable range for you. So let's look at, so this is kind of like the basic method. We've got this, we'll call this reset. And we'll call this FM shape. Just so we know what the hell we're doing. Always helpful. And I think it's useful just to leave this on the full amplitude. That way we're cycling through the entirety of this shape. But having the frequency control here definitely is useful as well. So let's simplify this shape here. Let's just make it a nice triangle wave. And you can set this up, however you want. You can do sine waves or square waves. It's also can be kind of fun to change this to points, and you can get some nice kind of video game-like . So that's a different kind of FM effect. So definitely, useful to play around with different shapes, different scaling modes, or I don't even know what you call this, different envelope interpolation types. Triangles are nice, just kind of basic FM shape that can yield some good sounds. And then, of course, you can use your modulation section to shape the sound further. So if you want this to have a different kind of amplitude characteristic, you can definitely do that. So let's say we wanted to have an envelope for the modulation of our FM signal. So we can do that pretty easily too, just by setting up a key tracker here and change this maximum value to 0 because we're going to be resetting with each key press. And then we'll set that to our third LFO reset here. And we'll send this to a custom shape and do a one-shot. And then you can just draw in whatever envelope shape you want. Oops, didn't mean to do that. It's always easier in the external editor. Come on. There we go. Okay, and we'll just put this down. And then we'll set this destination to our, let's see, where do we want this? We want this to be, I think it's the amplitude of FM shape. Let's just see here. So let's go to FM shape, amplitude. We'll try that. I'm not sure that's what we want as our destination. So then, depending on our amplitude envelope, we can, have different kind of behaviors in our FM scaling. Through this envelope as well. And we could, say we wanted the amount to scale by velocity. We could then set up a velocity tracker and have that point to the amplitude here. Sky's kind of the limit. But I just wanted to show there's kind of added levels of control that you can introduce using this method. Now it is kind of basically monophonic. I mean, you can have like polyphonic. You can play polyphonically, but it's going to all be going through the same pitch envelope or pitch modulation. So it's better for monophonic sounds, I guess is what I'm getting at. And then of course, you can send this through all kinds of audio processing effects chains. You can resample it. You can use those as starting waveforms. A nice technique is you can stack multiple waveforms here, which is kind of cool. So it's really easy to build like rich and interesting and unusual sounds. Let's pull in a saw wave here. And we'll bring this down an octave. Maybe. One thing you will run into is that, often you'll get like extra noise, unwanted high frequency content. So you probably want to put a low pass filter on it. I tend to use this method more for like sound generation and then, generating samples or other starting waveforms and using those kind of in more traditional ways. But this is great for resampling. You can always like make all kinds of squelchy, noisy mud pies and then grab snippets of it and sculpt those further. So I think that's pretty much all I wanted to show you guys. There's a lot of room for creativity and exploration using this method. You don't have to use an LFO here. You can use a formula device that can trigger faster than one line per cycle. But this is maybe a little simpler method for people who are uncomfortable with a formula device. Again, this is just scaling through this LFO because it's controlling the reset rate, or the reset position, I should say. Yeah. All right. That's what I got. It's maybe an improved method for FM synthesis and renoise. Pretty quick and easy to set up. You can save this as an instrument and then drop in whatever waveforms you want, and create whatever effects chains for audio processing you want, and then just have it at the ready. And it's a pretty useful and flexible method for creating some FM sounds natively within Renoise. All right. Do all the YouTube stuff. Check out my Gumroad. Oh, I got a new album out. Check out my Bandcamp. It's some high-tech, dark side type stuff. If you enjoy that sort of thing, you might find it to be the sort of thing that you enjoy. It's called Super Sane. And yeah, give it a listen. And yeah, if you got any questions or comments or anything, hit me up in the comment section below. All right. Have a good one. Peace.